Hello everyone, this is the beginning of Unit 9, this is Lesson 91. What we're just coming from is Unit 8, which is a unit on sampling. So typically, these two units, Unit 8 and Unit 9, are done as one unit. They're one chapter in your textbook. And the reason why is because there are a lot of similarities between sampling and doing an experiment, especially when it comes to how you actually randomize, like using HAT method or using check technology. However, there are some very significant and important differences between the two, and I think that it's easier to keep them separate in your mind if we keep them separate as units. So, that being said, we start this unit with how an experiment, like the fundamental difference between an experiment and an observational study. So, in contrast to sampling, now remember, sampling refers to taking a sample survey, so asking people questions or observing what people do. So, in contrast to sampling, experiments don't just observe individuals or ask them questions. So in contrast to sampling, experiments don't just watch or ask. Experiments deliberately impose a treatment, to measure a response. So one of the experiments, an example of an experiment that we've seen in our notes, is the mice with lung tumors. We inject a medication into the mice to see if it shrinks their lung tumors. That's what they mean by treatment. It's the medication that we inject. So they deliberately impose a treatment to measure a response. So we're getting involved. We're actually interacting with, a lot of the times, the individuals in our experiment. The purpose of an experiment is to determine whether the treatment causes the change in the response. So causes change in the response. The goal of an experiment is to understand cause and effect. So if you watched my hints for the Unit 8 review, you know that one of the problems was addressing how observational studies cannot determine causation. Observational studies can show correlation, but they cannot show cause and effect. So we have 3 examples below. We're going to decide if they're an observational study or an experiment and how we know which is which. So an educator wants to compare the effectiveness of computer software for teaching biology with that of a textbook presentation. So we have computer software or just the regular old textbook. She gives a biology pretest to each of a group of high school juniors, then randomly divides them into 2 groups. One group uses the computer, the other studies the text. At the end of the year, she tests all the students again and compares the increase in biology test scores in the 2 groups. Is this an observational study or an experiment? One thing to keep in mind is that when we are dealing with an observational study, we a lot of the times can do that without our individuals, our people in our sample, even knowing that we're doing it. In this case, that is not possible because the teacher randomly divides them into the 2 groups. So this is an experiment. This is an experiment because there is random assignment. This teacher randomly assigned the students or randomly divided them into two groups. So here, this randomly divides them is the key. Example 2, one study of cell phones and the risk of brain cancer looked at a group of 469 people who have brain cancer. The investigators matched each cancer patient with a person of the same age, gender, and race who did not have brain cancer, and then asked about the use of cell phones. So, two individuals, we're putting them in a pair. One of the individuals has brain cancer, the other one does not. All the other things about them should be as similar as possible. So age, race, gender, all the things that you can control without creating bias. So they ask each person in the pair about their cell phone use, and they look at the use of the person that has brain cancer compared to the use of the person that does not. And in the end, they concluded that the data suggests that the use of handheld cellular phones is not associated with the risk of brain cancer. So this is an observational study. And really, your text calls this an observational study, but I think what it really is a sample survey. They pair these two people together and then ask about their cell phone use. But I think that they're using this term observational study like they should be using the word sampling. So the researchers did not assign individuals to a treatment. If this were a true experiment, we would, in the pair, we would assign one of them to use their cell phone a specific amount and maybe the other one not to use their cell phone at all. And then we would have to see if one of them developed brain cancer, which would be probably a very long-term experiment. So in this case, an observational study is one of our only options, but unfortunately it cannot show causation because we did not randomly assign anybody to a treatment. And here I wrote the researchers did not assign individuals to a treatment, but it's really important that we know that the assignment needs to be random. So they did not. I'm going to add in a little caret underneath and write randomly. Because not only does there need to be assignment, but it needs to be random assignment. Then last, a study of child care enrolled 1,364 infants and followed them through their 6th year in school. Study of child care enrolled infants and followed them to their 6th year of school. Okay, so I think what they're meaning here is they probably had these parents volunteered for this study. So these children were enrolled in childcare. They were infants, and they followed them until they were in kindergarten. So from the time they were babies to kindergarten. Later, the researchers published an article in which they stated that the more time children spent in childcare, from birth to age 4.5, the more adults tended to rate them, both at age 4.5 and at kindergarten, as less likely to get along with others, as more assertive, as disobedient, and as aggressive. Does this study show that child care causes children to be more aggressive? And the key word that you're looking at here is, was it the child care that caused these children to be more aggressive? Well, we can't determine that from this study because this is an observational study. These children were not assigned to a treatment. And really, remember, we know that that actually has to be random assignment. Researchers only asked the teachers of these children to rate their behavior. So issue here is we did not assign these children to treatment groups. Like they were enrolled in daycare, but really we probably in the very least should have split them into two groups and randomly assigned one group to be enrolled in daycare and the other group to stay at home with one of their parents, which if you really think about that can be, I don't know how realistic it would be for these researchers to be able to do that, because you'd have to have all of these 1,364 parents be able to stay at home and take care of their kid if that's the group that they were assigned to. So you probably could only do this as an observational study, which can show there's a relationship, but can't show that there's causation. Observational studies do not determine causation. Do not determine causation because there is no random assignment. That is the biggest and most significant difference between the two things. In sampling, we can randomly select our sample, but we're not randomly assigning them to a group or imposing a treatment. So the biggest difference between an observational study and an experiment is that a study has random selection, but an experiment has random assignment, and it's the random assignment that allows you to show causation. The reason why is because without random assignment, there could be other variables influencing the behavior of these children. And one really good example of this idea, that there might be other variables influencing the behavior, is a study that was done a long time ago. I believe it was in 1972 maybe, where researchers were investigating the effects of delayed gratification. So there's this idea that we all have this skill. Some people refer to it as willpower, as this ability to be able to delay gratification. So one of the most common examples of this is being able to save your money to buy something you really want. So instead of, going out to lunch with your friends and going to Starbucks and getting little things here and there, you say no a lot. You delay until you can get the thing that you really want. So they did a study on this idea of delayed gratification. So they had several kids participating. They were all under the age of 5, I believe. And they would go into a room with a researcher one at a time, and the researcher would put a marshmallow in front of them. And he would say, I'm going to leave the room for 15 minutes, and when I come back, if the marshmallow's still here, I'll give you another one. But if you eat it, then that's all you get. So the kids would either have to delay gratification so that they could get the second marshmallow, or they could just eat the marshmallow. So what they found was, because the kids, obviously, they did different things. Some of them waited for the other marshmallow, some of them didn't. But what they found was that the kids that waited had better life outcomes. So what do we mean by better life outcomes? Well, there's different ways to measure that, but some of the most common are your SAT scores, your educational attainment. So did you graduate high school? Did you go to college? Did you get your degree? Your body mass index. So are you healthy? And lastly, things like the rate of substance abuse within these groups of kids. So they found that the kids that waited had better life outcomes. Their SAT scores were higher. They were more likely to graduate high school, go to college. Their BMIs were lower, and substance abuse among that group of kids was less likely. So the question here is, did waiting for the second marshmallow, and I'm writing this on the back of our packet, so the back of our experiments packet, I'm writing this on the back. Did waiting for the marshmallow cause the better life outcomes? And I want you to really think about that. Was it the fact that they waited what caused these things? So if I just sit in a room 15 minutes, wait to be given a second marshmallow, am I going to start to have better life outcomes? And I'm hoping that lots of you guys are recognizing that idea is kind of silly. Like, I hope that you're doubting that just waiting to eat the marshmallow is what really caused these things. That's what this last statement on our note sheet means. There could be other variables influencing the behavior of these children. Well, what really caused these better life outcomes was these kids' ability to delay gratification. It is this other variable that caused this. It is also what enabled them or caused them to wait for the second marshmallow. We have this other variable hanging out that is what caused both of the things that they were looking at in the observational study. This is why random assignment is so important, because you could have these other variables that you're not considering that's really causing the change. This is the idea of confounding. So this leads us into the second page of our notes, which is confounding. So we're going to look at confounding through an example. Last year at WJHS, they offered an after-school SAT prep class that students could volunteer to take. So one of the important things to acknowledge here is that students could volunteer to take this class. So I'm going to highlight that. 44 students took the course and then took the SAT. The average SAT score for this group was 1,220. The average SAT score for all students who did not take the prep class was 1,050. Can you conclude that taking the prep course will cause a student's SAT score to increase? And hopefully we're all recognizing no. We cannot show causation, in the very least because this is an observational study. But the bigger reason is there's confounding here. So no, students who volunteer to take an SAT prep class might be different than students who do not. It could be that these students are highly motivated to do well. We don't know if the prep class caused these students to score higher or if being highly motivated did. So what we're saying here is it could be this other variable that is causing these SAT scores to be higher. This is confounding. Confounding occurs when you cannot tell which of the variables is really causing change in the response. And the best way to model confounding is similar to the graphic I drew on the back of our notes. So we have an independent variable, which we often refer to as the explanatory variable. Explanatory because we think it's going to explain what happens in the dependent variable. We often refer to that as the response variable. So these descriptors, I think, make way more sense than independent variable, dependent variable. Really, we refer to them as the explanatory variable and the response variable. We think that this will explain the response in this. When we're talking about confounding, what's really happening is there's this third variable that is causing both of these, and that's what makes it look like this is the cause. So one of the more interesting ones that I think it's obvious that there is not a causal relationship is that it is shown if you do a scatter plot of the ice cream cells against the number of shark attacks in a certain area, you will see positive association. So if you did a scatter plot, and I'll just draw a rough sketch, and we had ice cream on the X and shark attacks on the Y, you would see a scatter plot that showed a positive correlation. So as ice cream cells increase, shark attacks increase. But we must keep in mind that are the ice cream cells causing the shark attack? No, they aren't. There's this confounding variable of temperature. High temperature is what is causing ice cream cells to increase. The high temperature is also what is causing the shark attacks. Why? Well, people are going to eat more ice cream when it's hotter, probably, to cool down. Also, people typically are in the ocean, in water where there are sharks when the temperature is warmer. So we have this other variable up here that is really the cause. It's not the ice cream causing the shark attacks. That's a confounding variable. Smoking's a good one. So it could appear as alcohol use causes lung cancer, which kind of seems like, really? I don't know about that. When really, it might be this confounding variable of smoking. Oftentimes, well, I don't know if it's oftentimes, but I do know that there are people that will smoke when they drink, and sometimes only smoke when they drink. So there's this idea that either the alcohol use causes the smoking or the smoking causes the alcohol use, but the smoking also causes the lung cancer. So that's why we're seeing this relationship, but it's not a causal relationship. It's just correlation. And then one last example is just the weight of infants when they're born. Lots of people think that it's however much weight the mom gains, like if the mom gains more weight, that's what causes the baby to weigh more, when really it's the length of gestation that is causing both. So the longer the woman is pregnant, the more maternal weight gain. Longer the woman is pregnant, the more the infant weighs. So here's 3 really good examples of confounding variables and the graphics associated. So now that we've gone through that, let's talk about this idea in terms of our SAT prep class example. So we think that it's the SAT prep class that causes the higher SAT score. So the question is, can we show causation? And the answer is no, because we have this other variable up here that's confounding, and we're calling that variable highly motivated. Well, let's talk about really quickly what highly motivated really would mean in this case. So this is our confounding variable. Okay, well, what would we consider highly motivated? Maybe their parents are pressuring them to get a high ACT score. So I had a student that graduated last year. The first time he took his ACT test, he got a 28. And his parents told him that he needed to take it again because his older siblings, one of them got a 35 and the other one got a 36. So I bet you this kid was highly motivated to score better and would probably have taken the SAT class to score better. The source of that motivation, though, is his parents. Maybe you're motivated because you need a certain score to get into the college that you want. Or you need a certain score for scholarships. Or maybe your whole identity is wrapped up in how well you do in school. So you're highly motivated to get the highest score that you can because you think that that's going to make you worthwhile. All of these can motivate a student to do well. So if they're highly motivated to do well, they probably are the kind of kid that volunteers to take the prep class. Because remember up here, I highlighted students volunteered to do this. Well, I'm probably going to volunteer to take this class if I'm highly motivated to get a good SAT score. That can also cause a higher SAT score, just being highly motivated. So notice, from the confounding variable has to cause both the explanatory and the response. So I want you to take like 30 seconds or longer, or however long you need, but really pause this video, and I want you to see if you can come up with a confounding variable. So what do you think could really be the cause of the SAT score? So really pause the video and try to come up with at least one. Okay, so some of the most common ones is an incentive. Maybe these students had some incentive to take the SAT prep class. Like, what if they were told, if you take this SAT prep class, you can take the SAT for free. We'll give you one free test. Or what if they have a teacher that says, if you go to this prep class, I'll give you 10 points of extra credit. So they had some kind of incentive to take the prep class. So free test, extra credit, etc. Another one is that the students have no extracurricular activities. Because I believe this is an after-school prep class. And then the last common one that I see is that these kids are smart. Smart or smarter. So let's just go in order and see if these are confounding. Well, for the incentive would cause us to go to the SAT prep class, but it's not going to cause the higher SAT score. The incentive is only going to get me to the class. This incentive that I get has nothing to do with the score that I get. So in order for this to be confounding, it would have to be, we'll give you a free test and pay you $50 if you get this certain score. Both of these would have to have a reward. So this is not confounding. No extracurricular activities. This would not cause either. having no extracurricular activities would make it able for you, or would make you able to attend the SAT prep class, but it wouldn't cause you to go to the class. It wouldn't be the reason that you went. It also would not be any reason to get a higher SAT score. I mean, it may allow you to have more time to study, but not having the extracurriculars did not cause the higher score. And then lastly, that they're smarter. Well, being smarter would cause a higher SAT score, but it wouldn't cause you to go to the prep class. I don't think it would cause you to go. In fact, I think a lot of kids that think that they're smarter think that they don't need the prep class. So I think that these three very good variables that could be confounding, these make sense to me why you would think they're confounding. They're actually not, because it has to cause both explanatory and response. So that's it for confounding. On your check for understanding, you're going to need to describe confounding. So I have given you some sentence frames that you can follow to do this, because the AP board is looking for very specific things when you describe confounding. This response here is also a good example of how they want you to word your responses for confounding. So you can use this as your guide, or you can use this one. We'll do this one really quick because it's a fill in the blank, and then you will be done and free to do the 2 questions. So, do smaller class sizes in elementary school really benefit students in areas such as scores on standardized tests, staying in school, and going on to college? We might do an observational study that compares students who happen to be in smaller and larger classes in their early school years. Identify a variable that may lead to confounding with the effects of small classes. Explain how confounding may occur. So, we have, sorry, I'm just looking for my paper. We have this explanatory variable of small classes, so small class size. And we're saying that it could look like this is causing better performance in school as you get older. So, better school performance as get older. The question is, what variable could be causing both of these things? So what is some other variable that could cause smaller class sizes, but could also cause you to do better on standardized tests, staying in school, and going on to college? One confounding variable here could be the parent's income. And really, a better descriptor than just parents' income is called socioeconomic status. So socioeconomic status is trying to explain that it's more than just parents' income. So yes, the parents do have a higher than average income, but they also have the resources and supports that come with that. So it's a matter of not just the income, but like what class you're in and what supports you have. And by class, I mean like social class, like social studies class. No, that doesn't make sense. The classes that you learn about in your social studies class. That's what I meant. So there's that. How I think about it is you have the money and you have all of the supports and resources that come with the money. So how would we describe that? The first thing we have to say is what variable we think would lead to confounding. So one variable that might lead to confounding is the income of the student's parents. Wealthy parents can afford to send their children to private school where class sizes are typically smaller. So, number one, it could be the income that's causing these students to be in smaller classes because their parents are paying for that. But that same income could also be the thing that's causing the better school performance because they can afford tutors. They can afford maybe to be home and be able to help their kids with their homework. They have other sources of support that come with this higher income. So we won't know if the small class sizes caused these students to perform better or if their socioeconomic status did. Now, if you feel uncomfortable with this phrase, socioeconomic status, then just put parents' income. Socioeconomic status is just a slightly better descriptor of what's happening. So back to how they want you to word your responses. One variable that might lead to confounding. Why? So how does it cause the explanatory? And then you must end with, we won't know if it was the explanatory variable or the confounding variable that caused the response. And that's how this other problem is worded. So students who volunteered to take an SAT class could be highly motivated. That's your confounding variable. We don't know if the prep class caused it or if the being highly motivated did. So, one variable that might lead to why, we won't know. Got to hit those three things. Now that I went back and read, this one's a better one to follow. Okay, so you try 1 and 2, and then your next lesson video is random assignment.